Hey everyone, and welcome. Today we're going to pull back the curtain on something we all use every single day, but probably never think twice about. We're talking about the invisible and honestly incredible journey your tap water takes to get to you.
I mean, really, have you ever just stared at a glass of water and thought about it? It's so easy to just turn on the faucet and have it there. But that clean, clear water has been on a wild ride through this hidden world of pipes and pumps and massive treatment plants. So come on, let's follow its path.
And this isn't just about having something to drink. For city planners, for architects, water is, well, it's everything. This quote really hits the nail on the head. The success of a brand new neighborhood or a skyscraper all comes down to a really basic question. Can we get enough clean water in? And can we get all the used water out? It is a giant engineering puzzle. Okay, so before our water can even start its trip across the city, it's got to get cleaned up. I mean, it shows up at a treatment plant full of all sorts of stuff. Dirt, leaves, tiny microorganisms. So its very first stop is this intense, multi-step cleanup process. So let's break this down. It's basically a 6-step spa day for water. First up, screening, which is just what it sounds like. It catches all the big stuff. Then aeration bubbles oxygen through it to get rid of any weird smells. Now here's the clever part, coagulation. They add chemicals that make all the tiny dirt particles clumped together. These heavy clumps then sink to the bottom during sedimentation. Next, filtration. It passes through layers of sand and gravel to catch even finer particles. And the final step, disinfection. A little bit of chlorine to zap any nasty germs that are left. Right, so now we have perfectly clean water. The next challenge is basically a huge math problem. How much of this stuff does a massive, sprawling city actually need every single day? Planners can't just wing it, right? They need a solid, reliable number to work with.
Which brings us to this number, 135. What do you think that could be? This isn't just a random number. It's the magic number at the very heart of all urban water planning. It determines the size of pretty much everything, the pipes, the pumps, the tanks, the whole shebang.
And here it is, LPCD. It stands for liters per capita day. So that 135, that's the baseline number of liters one person in a big city is expected to use every single day. And that covers everything, drinking, cooking, showering, all of it. This is the fundamental building block for designing an entire city's water system. Now, what's really fascinating is how this number changes depending on where you are. So at home, yeah, you're using that 135, maybe up to 150 LPCD. But at the office, the calculated need plummets to just 45 LPCD per person. It just goes to show how planners have to juggle these different demands all across the city grid. The city's water supply isn't always perfectly consistent. So buildings are actually required to have their own little water bank. Each building has to store a full day's supply for everyone inside, and this is usually split between 2 tanks, a huge one underground, the UGT, and a smaller overhead tank, the OHT, that you might see on the roof. All right, let's get into the final leg of the journey. We've got clean water, we know how much we need. Now, how does it navigate that incredible maze of pipes under our streets and up through our buildings to finally reach your tap? So under our feet, there are a few main ways to lay out all these pipes. You've got the dead-end system, which looks kind of like a tree with branches. It's cheap, but the downside is water can get stuck and go stale at the ends. Then you have the much better systems, like the gridiron and the ring system. Here, all the pipes are interconnected in a loop. So what does that mean? It means if one pipe breaks, water can just be rerouted from another direction. It's way more reliable. Okay, so the water has reached your building. Now it has to fight gravity to get to the top floor. The old school way is a gravity system. You pump all the water up to that big overhead tank on the roof, and then gravity just does all the work, feeding water down to the floors below. It's simple and super reliable. The modern way? A hydropneumatic system. This uses a set of pumps and pressure tanks to keep the water pressure high in the pipes at all times. No need for a giant tank on the roof. The trade-off? It's totally dependent on electricity. And this is really where the future is heading. To save our best drinking water, new buildings are being built with dual pipes. So one pipe brings that high-quality, potable water right to your kitchen sink. But a second, totally separate pipe system brings in recycled water. Water that's been treated but isn't for drinking, for things like flushing toilets or watering the garden. It's just a much smarter and more sustainable way to do things. All right, you've come on this whole journey with us. You've seen the cleanup, the math, the maze of pipes. So let's see if you've been paying attention. Think you've got what it takes to be a water planner? Let's find out. Time for a quick quiz. Okay, First question for you. Think back to that treatment plant. What's the name of that process where a chemical is added to make all the tiny bits of dirt clump together? Take a second. If you said coagulation, you got it. It's B. Yeah, you can think of it like a chemical matchmaker, just forcing all those tiny dirt particles to pair up, get heavy, and sink right to the bottom. Question number 2. We were talking about the different ways pipes are laid out under a city. Which one of those systems can end up with old, stagnant water just sitting at the very ends of the lines? And the answer is C, the dead-end system. It makes sense, right? Just like a dead-end street, the water flows to the end and has nowhere else to go, so it just sits there. And for our final question, let's talk about those tall buildings. What is the main reason you'd install a hydropneumatic system in a skyscraper? And the answer is B. That's the big win with these modern pump systems. You get great, constant water pressure on every single floor without having to build a massive, heavy water tank on your very valuable rooftop space. So there you have it. The incredible, invisible journey that ends with a simple glass of water. Kind of makes you appreciate it a little more, doesn't it? And it leaves you with a final thought. With those dual piping systems becoming more common, the next time you turn on the tap, just think, there's another pipe right next to it, carrying recycled water. And you might wonder, what color is that pipe? Well, to make sure no one ever mixes them up, they're coated with a specific color, a bright, unmistakable purple or magenta. Pretty cool, huh? Thanks for joining me.